motion on a straight line. It is a fundamental lesson in physics in grade 10, where you learn about the physical quantities and their calculations and end up with some motion graphs. So most of the students find a difficulty in these basic concepts of physics in order to completely write the answers for motion related questions. So today we are bringing you this video explanation on explaining the terms when you are supposed to write the answers for motion related questions. So before we go for the video today, if you have not subscribed us yet, do subscribe now and click on the button below as well as the bell icon to get updated about our latest videos. So the question today that we are going to take here, it's related with the motion calculations and the graphs. All right, let's look over the question there. An object started its motion from rest and acquired a velocity of 40 ms-1 within 8 seconds. Then it moved for another 8 seconds at the same velocity. Finally, it decelerated for 4 seconds and stopped at a point. Right. So usually, if there is an object to move on, it does have 3 types of motion. That is uniform velocity or constant velocity, uniform acceleration or constant acceleration, and uniform deceleration, constant deceleration. So these motion could be changed as average also, like constant velocity, average velocity. You see here, the question says that the object is started from rest. Remember, if there is an object starting its motion from rest and it comes to rest, the word rest refers for velocity is 0. So here the starting velocity is 0. So starting velocity is 0 and acquires a velocity of 40 means it's increasing the velocity. So if an object is increasing the velocity, it is said to be acceleration. If it is decreasing the velocity, it is called deceleration. So it's clear that during the first 8 seconds, it is moving at uniform acceleration. All right. And then the second 8 seconds, it's moving at the same velocity. Throughout these 8 seconds, it's moving at the same velocity. All right. And then the last 4 seconds, it's coming to rest, being decelerated. And now, the first part of the question says, sketch the VT graph to represent the motion. So now we are going to draw the VT graph, the velocity time graph. So since the object is starting from rest and acquiring a velocity of 40 ms-1, it is said to be uniform acceleration. So here, there are 2 methods to use. One, each and every point, that means 1, 2, 3, 4, 5, 6, like each and every point we can represent. Or else, only the data is given in the question we are going to represent. So I'm going to choose the second method. It is the easiest way. So the starting velocity is 0, ending velocity is 40. So 40 ms-1 I represent here. And what's the time taken for this? The time taken for this was 8. Right? It was 8 seconds. 8 seconds. And then it is moving at the same velocity for another 8 seconds. So when I'm taking another 8 seconds, the gap that I have taken here as same as the gap I'm going to take, right? An approximately equal gap I'm going to take because I didn't measure 1, 2, 3, 4, 5. So accordingly, approximately the same, or else even you measure by the ruler as 1, 2, 3, 4 centimeters, and then you can mark it. So anyhow, since it is a constant velocity, this is the way we show the constant velocity. So I end up at this point. It is 16. It's 16. And the last 4 seconds should be deceleration. Deceleration is given as a negative gradient, and the time should be half of this because only 4 seconds. So concerning about that time, I draw the graph accordingly. So here it should be 20. So accordingly, this is the velocity time graph for the question given. So let's take the second part of the question. Calculate the acceleration within the first 8 seconds. How do we find out the acceleration? Number 2. Acceleration is equal to final velocity minus initial velocity dividing by the time taken. Final velocity minus initial velocity dividing by the time taken. So here, when you consider starting velocity was 0, final velocity is 40. The time taken 8. Accordingly, 40 minus 0, final velocity 40, between the first 8 seconds, during the first 8 seconds, final velocity 40, initial velocity 0. It's ms minus 1 dividing by the time taken 8 seconds. 8 seconds. So 40 dividing by 8, it gives you 5, and acceleration is measured as ms minus 2. Accordingly, it is 5 ms minus 2, the acceleration. I can find out the acceleration in another way, that is using the graph. How do I use the graph to find out acceleration? Acceleration is equal to the gradient of the graph. The gradient of the graph. So how do you find out the gradient? Delta y over delta x. The difference between the y coordinates dividing by the difference between the x coordinates. That is how we're gonna. So accordingly, when you take this graph, the y coordinates are 0 to 40 and x coordinates are 0 to 8. 0 to 8. So I'm going to take the y coordinates. It's 40 minus 0. Why? Since we are taking the difference, we subtract as 40 minus 0. So 40 minus 0, the unit is ms minus 1 dividing by x coordinates 8 minus 0, and it is time in seconds. So the same way you get the answer, the final answer will be 5 ms minus 2. When you come for the questions, if the question says to use the graph, definitely the second method you have to use. If you use the first method, you're gonna not get marks for. And if the question says use equations, first method you have to use, not the second method. If the question does not apply either any of these two methods, whatever the method you can use. So let me take the third question there. What is the displacement traveled by the object at constant acceleration? So how do we find out this distance? Remember, displacement is also a sort of distance. Displacement is also a sort of distance. And in fact, that is the shortest distance, right? So displacement is equal to velocity into time. But here we have to take the mean velocity into time. Why mean velocity? Because no uniform velocity is applied here. Starting one velocity, ending another velocity. So two different velocities means we have to find out the average. So average velocity, how do you take? U plus V dividing by 2. Then we have to multiply by the time taken. So what's U here? Starting 0. What's V? Final 40. So 0 plus 40 ms minus 1 dividing by 2 to get the average, and multiplying by what's the time taken? It's 8 seconds. So how much you get here? 40 dividing by 2, it's 20. 20 into 8, it is 160 meters. So the displacement during the first 8 seconds, it is 160 meters. So how do we find out the same? Using the graph. Using the graph, displacement is equal to the area of the graph. So it gives you a triangle. So half into base into height. So the base is 8, and I have to take it as seconds, and into what is the height here? 0 to 40, it's 40 ms minus 1. So the same way you can find, right? You have to simplify, you get the answer 160 meters. Next is the question number 4. What is the displacement traveled by the object with constant velocity? What is the displacement traveled by the object with constant velocity? During the first 8 seconds, it was the uniform acceleration. The second 8 seconds, it is the uniform velocity, the same velocity it's traveling. So how do you find out the distance, or the displacement is equal to directly velocity into time? You don't want to find out the mean velocity because only one velocity is applied. One velocity, that is 40 ms minus 1 into what's the time taken? It is 8 seconds. So 40 into 8, 320 meters. So the same part, if you are going to use the area using the graph, area, it is a rectangle. So I have to take it as a length into width. So I'm going to take 8 to 16, it's 8 seconds into the upper part, we take 40. So 8 into 40, it also gives you the same answer, 320 meters. So heading up with the next question, question number 5. Calculate the deceleration of the object during the last 4 seconds. How to find out the deceleration? Deceleration is the negative acceleration. So the same method, you have to apply A equals V minus U over T. Finally, you get the answer in a minus value, a negative value. So here there is a point where usually the students get confused. That is, the object starts from this point. So this should be the initial velocity, which is 40 ms minus 1 as for this question. And the final velocity should be this point where students get confused it as a 20. Some of the students 20 because of the number given 20 here. But remember, what you get is from the vertical axis y. So that should be here the point, it's 0. So the final velocity is 0. Starting velocity is 40, final velocity is 0, right? And the other problem is when you are getting the difference, you have to take it as final minus initial, that means 0 minus 40. But the second mistake that commonly being done is again you're going to take it as 40 minus 0. That's wrong, because the final velocity is 0, initial velocity is 40. So I'm going to take it 0 minus 40, it's ms minus 1, dividing by the time taken, it's 4 seconds. So 40 dividing by 4, it's 10, and it is minus here, minus dividing by plus, it's minus 10 ms minus 2, and that is acceleration, right? So I can exchange these signs in order to give minus a. So minus a becomes equal to plus 10 ms minus 2. That means the deceleration here is 10 ms minus 2. So how do we find out this answer using the graph? Acceleration is equal to gradient and deceleration is equal to negative gradient. Negative gradient, the direction changes, right? So that means minus delta y over delta x, minus delta y over delta x. So this minus is there here, and delta y, it's 40 minus 0, 40 minus 0, right? Dividing by delta x, it's 20 minus 16. So how much? 40 minus 40 here, right? Dividing by 20 minus 16, it's 4. You get the answer. Minus 10 ms minus 2 is a. That means deceleration is minus 10. So the next part is calculate the total displacement of the object. You have to find out the total displacement. So already we found the displacements during the first 8 seconds. It was 160, and the second 8 seconds was 320. Now the third one you have to find out. Displacement equal velocity into time. So since it is deceleration, I'm going to take u plus v dividing by 2 multiplying by the time taken. Starting velocity here, it's 40 plus final 0 ms minus 1 dividing by 2 to get the average, multiplying by 4 seconds. 40 dividing by it's 20, 20 into 4, it's 80 meters. That means during the last 4 seconds, the displacement is 80. So now we're gonna find out the total. So the total displacement, right? Total displacement is equal to, first we found it was 160, and the second 8 seconds was 320, and now we found 80. So the final answer here is 560 meters. 560 meters. So that is the total displacement after 20 seconds. How do we find it out using the graphs? Using the graphs, it's very easy. Displacement equals to the area of the total graph. So since it is a trapezium, we can go for half into sum of the two parallel lines into the vertical height. Sum of the two parallel lines, here it's 20 and here it's 8 to 16, that means 8. So I'm going to take 8 plus 20, that should be in seconds, into the height is 40 ms minus 1. Here too you get the same answer. If you're gonna simplify, it's 560 meters. Accordingly, these are some possible questions that could be asked related to these VT graphs. I hope that the lesson we did today should have benefited you in revising, recalling the theories you have learned, and to clarify if you have got any doubts related with. So at last, thank you for watching our videos, and make sure do subscribe our video channel Science with Anas Mohideen in order to get the latest updates on the new videos.